Alright, so here's part 2 of that homework for geometric sequences. So again, we're trying to find the 5 means. So it's like negative 160, and there's 1, 2, 3, 4, 5. And then negative 5 over 2. Now, to understand how to find the common ratio, we're going to do a few things. So first, we're going to count how many terms are there. 1, 2, 3, 4, 5, 6, 7. So we're going to go 7, take away 1. Kind of like you would do if you're doing the slope formula. So I know it's the 6th root. So I can either count 1, 2, 3, 4, 5, 6, or I can go 7, take away 1, and get that answer. Then I'm going to divide. So I'm going to take the last number, and I'm going to divide, which means times the reciprocal. So instead of dividing, I'm going times the reciprocal. So it's the 6th root of, and it's a positive answer. Let's see, 5 over 160. So use your calculator, goodness sakes. Where's my calculator? There it is. So simplify it. It's okay to use your calculator to do it. So it's 1 over 64, and the 6th root of 1 is 1, and the 6th root of 64 is 2. So it's 1/2. Then all you have to do is then multiply by a half. So that means half, 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 and then do you see how it fits? It'd be a fraction at the end. So those are your 5 geometric means. So let's try it again. So step number 1, to find the common ratio. So in other words, you can add 1 to whatever means you're finding for the index. So if I want to find the ratio, add 1 to that. So it's the 4th root. And then the last one divided by the first one. So negative 6 divided by, or negative 96 divided by negative 6. So 96 divided by 6 is 16, and the 4th root of 16 is 2. So that's what I'm going to multiply times. So negative 6 times 2 times 2 times 2 times 2. Oh, that's too many. I just need 3 of them. There they are. And it fits. So it's nice to do the last one so it matches. One more time. So 1 means, so it's going to be square root. And we go, because 2, index 2 means square root. And we're going to go 147 divided by 243. So 147 is a half divided by 243. No, but it reduces down to 49 over 81. So this fraction reduces down. So the square root would be 7 over 9. And then that's what you multiply it. So go that times 243, and the answer is 147. Right? So the R7, did I not do it right? 7 over 9 times 243 7 over 9 times 243 is 189. I don't know, I didn't get that the first time. So the one mean in between is 189. All right, number 20. In 2000, Eric started a new job with a yearly salary of $52,000. If the company offers a 2.5% raise each year, use a geometric sequence formula to determine his salary in 2020. So let's break it down. So the general formula is A1 times R to the n minus 1. What we're trying to do is, we started in 2003, so in 2020, how many years has gone by? So well, let's start here. A1 is 52,000. Now this one's just a little trickier. If I want to know how many terms there are between 2003 and 2020, not only do I subtract them, but then I got to add 1 at the end for the counting principle. So how many terms are there altogether if I'm starting at 2003? So the number of terms is actually 18. And then the rate. Well, the rate that it goes up is 2.5%. Now, if I use that as a decimal, all I would be doing is seeing his raise every time. So not only do I want to know the raise, I want to add it back in. And so the mathematical way of doing a percent increase and have it added back in is we need to have a 1 in front. So 1.025 is the raise, and then you add it to 52,000. So together with the raise, you'd have your new salary. So it needs that 1 in front, so it adds it back in. So now we're ready to go. The 18th term, so A1 is 52,000. The rate is 1.025, and then the exponent, n minus 1, which is 18, subtract 1. And there you go. So we have 52,000, 1.025, and then the exponent is 17. So rounded, his salary in 2020 would have been $79,124.15 if you round it. All right, last one for your homework. A ball was dropped from a height of 125 feet. Each ball, the bounce loses 4/5 of the height of the previous bounce. If this pattern continues, use a geometric sequence to find the height of the ball of the 6th bounce. So the first time it bounces, it's 125. That's the first term. The ratio is going to be 4/5. Now we don't need a 1 in front or anything because 4/5 means it's getting smaller and smaller and smaller by that number. And what I'm looking for is the 6th term. So to find the 6th one, we take A1, we take the ratio to the exponent 6 minus 1. You can use your calculator and round. 40.96 feet is the answer. All right, GMath over out. Good job doing your homework. Proud of you.